Continuing 7.5, Human Interaction with Landslides. And road construction. Road construction is often at the base of a slope, and the toe of the slope is critical in keeping the rest of the slope in place. Remember, mass and slip plane area ratios. And if the road is higher on the slope, there is a potential of improper grading that adds more weight to the slope or cuts into the potential slip plane. Building at higher elevations usually just means building on steeper slopes that have better views, but also think a higher risk for landslides. Improper grading is bad when building homes too, and placing fill materials on slopes just adds weight. Irrigation and septic tanks also adds weight. Heavy water. The images on the right illustrate some of the concepts. Top image is a cartoon of some unfortunate houses. We have exposed bedding planes that slope downhill, daylight beds. Each bedding plane a potential slip plane. The grading to make benches cut into the toe of each of these small slip planes, the daylight beds, as well as added extra weight to the downslope area with cut fill. The cesspool septic tank will add water weight to the hill, as well as the home itself. Potential buyers of these homes should take a walk around the property and notice developing cracks both up slope and down slope from the house. Oh, they are going to fall down. Expensive fixes to the foundation, etc., perhaps even catastrophic failure. The bottom image shows a slump stimulated by a road that removed some of the toe of the slope. This road will always have issues, but it's not a very expensive road, so it might not matter much, just based on the picture. Timber harvesting can also increase landslide activity through clear cutting, i.e., removing all of the trees from a defined area, potentially removing anchoring vegetation, and through road building, i.e. building of a network of logging roads, often cutting into the toes of slopes. This increases erosion, i.e. soil slips, on geologically unstable land, and also interrupts surface drainage, alters subsurface movement of water, and changes distribution of earth materials. Environmental unity. Change causes change, and that change on a mountain slope often involves moving some mass around. But we're not all bad. Humans can decrease mass movement through properly grading of land surfaces, building stabilizing structures, and improving drainage. We'll talk more about this in a bit. 7.6. Minimizing the landslide hazard. There's lots of ways to minimize the landslide hazard. Properly grading can increase slope stability. When material from the upper slope can be moved to the base, reinforcing the oh so important toe. The image to the right is some grading in an open pit mine. Notice that there is still some mass movement, but the mass stopped on the next bench. We'd have to investigate further to determine if this slope was properly or improperly graded. Slope supports can also help prevent a landslide. These supports include retaining walls constructed from concrete walls and/or gabions, piles, and deep-rooted vegetation. The cartoon to the right has a concrete retaining wall. Please notice the oh so super duper important drains. The water must have a way out of the soil, or else. What do you think the consequences are of water piling up behind a retaining wall? I can think of a couple. 1. Wet soggy slope is heavier, and therefore more prone to slide, even with a retaining wall. And 2. Water behind a wall in a cold area with freeze-thaw action can weather a retaining wall quickly. Gabions have built-in porosity, right? Rocks piled in cages that let the water seep out, no problem. The cartoon also has piles that extend through the potential slip plane. If the piles stop short of the slip plane, then we've only succeeded in adding weight to the slope. Dope. Piles are often made of reinforced concrete. And the pine trees usually have deep tap roots that could extend through the slip plane. They also suck up water from the slope, which may have a net decrease in weight on the slope. Drainage control attempts to keep water from infiltrating a slope. Two examples in the figures below. On the left, a ditch rerouting surface runoff away from the slope. And on the right, soil cement on the slope surface to prevent rain seeping into the slope. I hope they did their homework. Otherwise, these mitigation strategies could backfire. Questions I'd want to ask include, where is the water collected by the surface drain going to go? Onto another slope? Is there any groundwater that wants to exit the soil cemented slope that will now just pile up in the slope? Hopefully, they know. Another mitigation strategy is a landslide warning system. The purpose is to provide time for people to evacuate. Options include human monitoring for changes or small rockfalls, and electrical systems such as tilt meters, geophones, slide fences, acoustic flow monitors, shallow wells, and rain gauges. The pictures depict several of these electrical systems. Top left image is a tilt meter. Top right is a slide fence. Bottom left is a rain gauge, and bottom right is of a geophone. Acoustic flow monitors and geophones both listen to the earth materials. The earth materials really only make sounds if they are moving. Rain gauge is obvious by now, hopefully. Water adds weight to the slope. More rain, more weight, more likely that the slope will slip. Tilt meters monitor if the land begins to tilt, which it might do before it gives way. Earth material tilting can also be monitored by satellites. And by the way, soil moisture can also be monitored by satellites. We're being watched. Identifying potential landslides can be tricky, but here are some dead giveaways. Crescent-shaped cracks or terraces on a hillside. Think of slump scarps. Tongue-shaped area of bare soil or rock on hillside. Large boulders or talus piles at the base of a cliff. Obviously a rockfall. Linear path of cleared vegetation extending down a hill. Exposed bedrock with layering parallel to slope. Daylight beds. Tongue-shaped masses of sediment at base of slope. An irregular land surface at the base of a slope. You might say it looks hummocky. And this information can be used to create slope stability maps or landslide hazard maps. The top image shows some crescent-shaped terraces upslope with some hummocky terrain near the base. The bottom image has a linear cleared path and a tongue-shaped deposition at the base that pushed the river over a bit. 7.7 Perception of and adjustment to the landslide hazard. As a community, we can move critical facilities such as hospitals, schools, and police stations to safe locations away from the landslide hazard, as well as other hazards. Also, as a community, we can correct landslide movement by stopping it after it starts, or directing it away from structures using drains and other prevention methods. Personally, we can also protect ourselves from the landslide hazard. There are the basic doomsday preparations like have an emergency kit and a plan of what to do, but you also have the power to avoid this hazard to a certain extent. If buying property on a slope, you can get a geologic evaluation of property. Avoid homes at mouths of valleys or canyons where there are often tongue-shaped deposition or deposits. Consult the correct local agencies about the landslide history and risk of your property. Monitor small landslides on the property. Are they indicative of some bigger problem? Look for cracks in house walls, leaning retaining walls, doors or windows that stick, etc. Be wary of leaks in swimming pools or septic tanks, trees or fences that tilt, or sagging or taunt utility wires, as well as small springs. And look for cracks in hummocky surface of soil. The image shows a beautifully located home by a river. Would you buy this property? Would you rent this property for a weekend? What if someone gave you this property? What would you do with it? How socially responsible are you? A common mass movement killer is avalanches. Even experienced backwoods people get killed by these. Be aware that most avalanches are triggered by victims or others in their party. If you go play in the backwoods in the winter, please obtain forecasts from the nearest avalanche center before you go out. Most people who survive avalanches are rescued by other members of their party, so know how to rescue others. Learn avalanche safety procedures and how to evaluate snow conditions before traveling into avalanche-prone areas. And on that cheery note, we end our mass movement discussion. See you next time.